All right, I am Heidi Hirsh. I am a PhD candidate at Stanford University on main campus in Palo Alto, calling in today from Mountain View. And I am going to share some work that I did down at Hopkins Marine Station, which is Stanford's Marine Station down in Pacific Grove on Monterey Bay, which Meredith mentioned before. And today I'm going to be sharing some imagery from some high temporal resolution mapping that I've been doing of the emergent kelp canopy, like Meredith just spoke to you about, there in southern Monterey Bay at Hopkins Marine Station. All right, so before I play this short little video showing the surface canopy, I want to point out a couple of things. This is the marine station there, Point Cabrillo, and there are two sides of this point that I want to point out. On this side, we have an exposed area that actually used to have a kelp forest, but right now it's an urchin barren. And then on this more protected side, if I start this video, that's where we see most of the kelp biomass. So this is a aerial video I collected in December of 2019. And so you can see that we see a lot of the kelp canopy there on the surface. And like Meredith mentioned, when we're mapping kelp with drones, we're looking at the surface area, not at the underwater biomass. So we're really looking at the area that we can actually see from the UAV. And, oops. So my background is in marine biogeochemistry, and that's what most of my dissertation has been on. And so I actually started getting interested in kelp forests from a biogeochemistry background of looking at how much carbon dioxide kelp take up and their potential to buffer ocean acidification. And so that's what originally brought me to Hopkins Marine Station. And one of the first things I did when I started studying this protected kelp forest was I opened Google Earth and used the historical imagery search function to look at the other satellite images that were available for this area. And I noticed right away, this was in 2018, I noticed that the images there were only 6 images between fall of 2016 and fall of 2018, which seemed really surprising to me that there wasn't more imagery available just on a platform that the public would check out, like Google Earth. And so I've included those 6 images here. This is the October 2016 image. This is from November of 2018, and that would have been once I started my flights. I'll talk about that in more detail in a minute. But in October of 2016, you can see that there's this exposed kelp forest there on the more wave exposed side of that point. Whereas after that period, you don't see that kelp there anymore. And that's because we had an El Nino event and a warm water blob that came in and really stressed out the kelp and led to a lot of die off. So now we have an urchin barren there where if you go diving, you won't see very much kelp and it's mostly just bare rock. And so I was really interested when I started the mapping to see, is there still kelp that exists on that exposed side, and can we pick it out through the aerial approach? And so the reason behind why there are only 6 images over those 2 years is that in Monterey, we have a lot of days that look like this. This isn't just a white box, this is a cloud cover between the satellite and the ground. And so you can see, or you cannot see, Hopkins Marine Station and the Monterey Bay Aquarium. And this is why it's really hard to use satellite imagery, particularly in the summertime, to map emergent kelp canopy in this area. And so one way that I thought we could get around this was using small drones. So by using these UAVs, we're flying under that cloud cover. So we don't have that issue of fog or clouds barring what we can actually see at the surface. And in doing it this way, we can actually see that kelp canopy. So in this photo on the left, you see me and my little drone actually flying under the clouds on a cloudy, overcast day. I'm doing this project with a relatively cheap consumer drone, the DJI Phantom Pro 3. It's surprisingly still going strong after, I think, 3 or 4 years of having it now. And I'm flying relatively low at 125 feet over the kelp. For comparison, when Meredith flies over the same site, she's usually flying at 350 feet altitude. So I'm just going to lead us through some of my planning and the approach to collecting this data. I'm using Drone Deploy for my flight planning and image processing. And As a side note, I am using this software because when I started in 2018, my first flight was in August of 2018, I did a comparison of the stitching in Drone Deploy versus Pix4D and Agisoft Metashape. And Drone Deploy was the one that would dependably stitch open water well, which was important for me since I was trying to map this exposed side of the point where we didn't have a lot of kelp in the water. And I just want to point out that I'm flying with a front overlap of 75%, side overlap of 80%, so that I get a lot of overlap since there aren't a lot of common features between the images I'm collecting, especially over that open water. So if I use my, actually this was my latest flight at the end of February as an example, these are the transects that I flew at Hopkins Marine Station. It required 5 flights total, and that's due to battery limitation. I usually get about 14 minutes to a flight, and luckily it takes long enough that I can charge some batteries while I'm going because I only have 4 batteries. But in total, I collect around 1,600 images each time, and you can see that I'm making a flight plan that includes both that area that I expect to see the protected canopy in, as well as where historically we've had that exposed kelp forest. And so if we bring up, these are the actual image outlines for each photograph collected on that flight. I forgot to mention, I'm just flying with a RGB camera, no multispectral or anything for this project, pretty straightforward. And then finally, we get our stitched orthomosaic image, which here I've overlaid those transect paths just so that you can see how it kind of extrapolates beyond the end of those transects. And in that area, sometimes I can't reliably trust as much of the stitching that's actually beyond where these transects are. So if we look at the stitched image from February, we can see that it did a really excellent job of stitching this whole area. We have the protected canopy over here. And once again, this is in the winter time, so it's relatively sparse compared to what we might see in the summer, which we'll see in a minute when I put the rest of my images up. But I also want to point out that on this exposed side, we're seeing what is likely kelp. And so if we zoom in, and if I add some boxes, in these areas, we actually, it looks like they're individual kelp sporophytes. And if I just zoomed in and screen captured yesterday to see what those spots look like. I am pretty convinced that these are kelp and that kelp are making up these pixels, but I haven't, at this point, I haven't gone and classified the exposed side yet, but this is a future direction. So if we go back to this full image, today what I'm going to show you is data looking at how the canopy has changed on that protected side. So the first step before I can classify anything, I mask out the land, and in this case I've masked out the whole exposed side of the canopy, just because there were a lot more waves in the winter months on that side and other things that made classification a little bit more tricky. So now I'm going to bring up all of my images so far. So over the last, I guess it's almost, we'll still call it a year and a half since I haven't flown since February. I've collected 13 different days of kelp maps starting in August of 2018 and then ending in February of 2020. And that was because since then we've been sheltering in place. The Marine Station has been closed, haven't had opportunities to continue this data collection. You'll notice that we also have some data gaps in other places. In the winter of 2018, 2019, it was exceptionally rainy and wet, and we can't fly the drone in the rain. And since I live in Mountain View, I tried to plan days when it wasn't gonna rain that I could go down and collect imagery. But even so, I had a lot of aborted trips where we'd go down and it would be too rainy to fly. So we missed those months. And then we also had a gap last summer in 2019 due to the black oyster catcher nesting season. And so we were working with monitors who were concerned that we might be disturbing those birds that were nesting during those months. Since then, we've developed a working relationship with the Black Oyster Catcher Monitoring Network, and they accompany us for our monitoring flights. So in these just stitched images, we can start to see that kelp cover. But the various lighting and things make it hard to actually compare month to month. You can see here in May, we had some glare issues. And then in the winter months, sometimes we have more foam and wave energy in this area. So this is where it's more helpful to go in and actually identify what is kelp and what is water. So to do that, I'm using a very basic threshold that was passed on to me from Tom Bell at UC Santa Barbara. And the first step, like I said, is to mask out everything except the kelp and the water. And this works in a kelp forest ecosystem because everything is generally kelp forest canopy or open water once you take out the shoreline. And I'm relying on the fact that water absorbs almost all of the red light. So we have very little red reflectance in open water. And so anytime we have blue reflectance less than red reflectance, we can assume that that's gonna be our kelp. And so that gets identified as yellow, which we'll see in a minute. And then for open water, that's any time that our blue is greater than our red reflectance. So we're using this just very basic ratio to determine kelp versus water. And so far it's worked pretty well. So these are the classified images. Again, they're masked. So where you see these kind of bites out, that's if no area was stitched in that portion of the image. I don't know where the label went saying the yellow was kelp, but the yellow is kelp. That's our classified emergent kelp canopy. And here you can see that in the summertime, we definitely have a more dense canopy. So here in August 2018, and then June and July of 2019, whereas in the winter, we start getting thinned out canopy. That's when the kelp is senescing and losing its biomass. There are fewer nutrients in the winter that support kelp growth. And so for instance, from October through February, we see that really nice loss of kelp canopy as we go into the winter months. And unfortunately, we don't see it come back again since I don't have the data. So a better way to compare this from month to month, I think, is to look at a bar graph. So I've plotted here bars that are kelp cover in meters squared. Note the 10 to the 4th here. And so this is all of my data so far. The upper right corner is showing the same maps I've shown on previous slides for each month. So you can see a side-by-side comparison. And we see that we had our highest kelp canopy coverage in July of 2019, which was very close to our August coverage in 2018. And then we had our lowest canopy in November of 2019, which was close to the winter canopy in 2018 as well. Ideally, we were looking to replicate this record, and we don't have that because of our little coronavirus here. But I'm hoping that in the future, this project can be carried on so that we can get a more complete temporal record on a monthly basis. And that brings me to the next steps. So my first step in the immediate future is to actually quantify any of that exposed kelp on the other side of the point. So this, I'd shown you an image from February of 2020 before. This is an image from October of 2019, where again, you can start to see kelp in the exposed side, or what we think is kelp. And then when we actually classify that whole image, those points are being shown as non-water, or what we assume is kelp. However, other things are also being classified, so that's why I've kept my analysis to the protected side for now. The other step I'd like to take is comparing these surveys to any available satellite imagery. I have Landsat imagery from Tom Bell that I haven't processed yet. So that's another step in the immediate future. And then I'm trying to compare this monthly record to higher frequency records in the past. So I'm working with the Monterey Bay Aquarium Conservation Research Group, who's georeferencing some kelp imagery that was collected in the late 80s and early 90s, which actually has monthly records for the late 80s and then bi-monthly and quarterly records in the early 90s. And those were images collected from aerial photography from a plane, but I'm hoping that might give me a comparison of monthly change over time. And with that, I'd like to thank all of you for listening to me today and for your attention. My email is here. If you have any ideas about how to bring this work forward or have questions about how we've built up this project, I'm happy to discuss those further. Big thank you to Hopkins Marine Station and Tom and Meredith for their help with this project.